Hi guys, we're going to cover section B and C today of chapter 18, and they're pretty intense. So I'm going to try to keep it as simple as possible. Okay. So I brought up the ozone layer to you the other day. Basically, we breathe O2, which is oxygen. Ozone is O3. It's three oxygen atoms bonded together into one molecule. Okay. So when O2 in the atmosphere is hit with UV radiation, UV light from the sun, it splits. You have two single oxygen atoms. Okay. And so that single oxygen atom is going to go find an O2 and hook up with it to become O3. Okay. So O3 is ozone. But it's not really a bad thing because O3 absorbs that UV even better. UV is what gives us sunburns and can cause skin cancer. It's actually really bad for us. Okay. So the ozone layer is super important. It's found up in the stratosphere layer of the atmosphere, and it mostly shields us from those harmful UV spectrum of light. Okay. However, pollution has caused holes in the ozone layer. There's actually a big hole in the ozone layer down by the South Pole. And it was discovered decades ago that certain kind of aerosol cans that had these compounds called chlorofluorocarbons in it were what was causing that hole in the ozone layer. And so they've been restricted and we've used them less, and the hole is actually shrinking. The problem is that the entire world shares the same atmosphere and shares the same ozone layer. So unless the entire world gets on board with being careful with pollution and what chemicals we use, if some large countries decide to keep doing this, even if we don't, it's not going to help that problem very much. And so it's important for the entire world to kind of do their part with this. Okay. Another section of the atmosphere that we did not talk about before is the ionosphere. Okay, and this is kind of part of the thermosphere. It's up there with like the exosphere and everything. Very, very high outer edge of the atmosphere. And it's got these ionized particles in it. An ionized atom is basically a charged atom, okay, positive or negative. And they form from the gas molecules being split apart from solar radiation. Okay, so we're going to talk about these things called solar winds in just a minute. So as the sun's hitting the atmosphere, there's all kinds of energy and there's a lot of radiation to it. And it can break apart some of these gas molecules and cause them to be ionized and charged. Okay. That layer of charged particles actually reflects radio waves. So radio waves are something that travel at different frequencies. When they are sent from, say, like a building or a radio show or something, they'll go up. Let me get my pen here. They'll go up and they'll hit this ionosphere and they'll reflect back down. Okay. When we use cell phones and other kinds of communication, you actually need to go all the way up past that to like a satellite, and then the satellite sends it where it needs to go. But radio waves can actually kind of bounce around within the atmosphere based on the fact that the ionosphere reflects those radio waves. Okay. This is also where the aurora occurs. So the northern lights and the southern lights. The northern lights are called the aurora borealis, and the southern lights are the aurora australis. Okay. This is a picture of probably the northern lights. They're more common. And basically it's when the solar winds come again and they start ionizing even more particles and they become excited and they start emitting photons. They start emitting light. Funky, crazy stuff way up high in the atmosphere. Super complicated, but if you get a chance, definitely a bucket list thing to be able to see. We also have this thing called the magnetosphere. It sounds like something from X-Men, right? But it's super important. It actually helps us not die from the sun. The sun helps us live, but if we weren't protected by the atmosphere and the magnetosphere, the radiation from the sun would kill us. Okay. So the magnetosphere it's formed by the magnetic field of the Earth interacting with these solar winds that come off of the sun. Okay. and it forms this kind of bubble around us that then gets those solar winds to go away from us. Okay, and I'll talk about what those are in a minute. The winds carry a ton of radiation from the Earth, and it would actually, it'd probably kill us if we were exposed to it too much. Okay, so this magnetosphere protects us from that. It also prevents the atmosphere from eroding away. So as those solar winds are hitting the gas particles in the atmosphere, they're splitting apart and becoming ionized. If they constantly hit the atmosphere, eventually the atmosphere will run out. Okay, so that magnetosphere prevents that from happening as well. All right, we're going to watch a video on solar winds because this is something else that's kind of complicated. So the sun has this thing called a corona around it. This is actually a picture that I took of a solar eclipse. Okay, and that white part we can't see. We can hardly look at the sun with our eyes. But there's this corona, this really hot part, kind of around the sun. Okay, there's a ton of energy to it. The surface of the sun is emitting a ton of energy. Okay. Sometimes these winds erupt away from the sun with such high velocity that it actually escapes the sun's gravity. Okay, and it comes charging towards wherever. It goes off in all directions, come charging towards us. And it contains a ton of radiation, a lot of high energy. Okay, those are known as solar winds because they're traveling so fast. If they hit us, it's bad. So the magnetosphere protects us from that. Told you I was going to keep it simple. Okay. All right. Last thing, greenhouse effect. I talked about the fact that carbon dioxide is a greenhouse gas, but what is greenhouse effect? A greenhouse, like an actual greenhouse, is something that's built in really, really cold climates, where it gets so cold that plants can't even grow. And so a greenhouse is basically a house built out of glass. The glass lets the sunlight in, the sunlight goes back out, but it keeps the heat inside. Okay, our cars do this during the summer. It gets even hotter inside of a car. This is why we're always told not to leave animals inside of our cars, because the light comes in the window, the light can go back out the window, but the heat of the sun gets trapped. Okay, our atmosphere does the exact same thing. So sunlight and heat enter the atmosphere. The light can keep going out, but much of that heat gets trapped in the atmosphere. And this is actually a good thing because without it, it'd be too cold for us to live. Okay. Water vapor and carbon dioxide are our two main greenhouse gases. Okay. So without the atmosphere, when the sun was on the other side of the planet, we'd freeze. It'd be so cold. There'd be no heat trapped, and we would freeze. Without it, the radiation of the sun would scorch us anyway, so it kind of wouldn't matter that we'd freeze because we'd probably be dead anyway. So, yay, atmosphere. Thank you, God. Okay. End of chapter. Bye-bye.